Okay. I just want to start by saying, to get into calculus, you took a semester of trig. Trig comes up, and so it's very important that you go back and review all those concepts. The intention behind this little review session is to kind of remind you of how we generated things, how we got things. But trig is a great thing to make flashcards of, and there are lots of resources to make flashcards and just kind of review all these basic facts. Okay. Now, that said, let me take a few minutes and remind you of how we generate these trig values. Way back a long time ago, you took a class called geometry, and in geometry, hopefully, they taught you about special right triangles. And let me try that again, make it actually look like a triangle. Okay. And in a 45, 45, 90 triangle, okay, somewhere along the lines, you should have seen the relationship that the sides opposite the 45 have the same length, and the hypotenuse, and you can use Pythagorean theorem to justify this, would be square root of 2. And similarly, in a 30-60 triangle, so we'll put 30 there and 60 there, the side opposite of 30 would have a relationship of 1. The hypotenuse is double that, and that meant the side opposite of 60 degrees was square root of 3. Okay. Now, those relationships, those sides, help generate sine, cosine values for trig functions. So that's what we're going to fill in this little chart here is based on those little triangles. Of course, it would help if we remind ourselves of what a radian is. Radian is just another way to describe an angle. And the formula for radian is that 180 degrees equals pi radians. Okay, so 0 degrees would translate into 0 radians. 30 would be pi over 6. 45 would be pi over 4. 60 is pi thirds. And 90 would be pi halves. Okay. And the cosine of each of these angles, so if we go back in and we look at cosine itself, would be adjacent over hypotenuse. Sine would be opposite over hypotenuse. So if we go back into each of these main angles and we label like 0, let's see, cosine of 0 would be, kind of remind ourselves of a unit circle here, would be right there. That would have a cosine value of 1. Cosine of 30, so if I go to 30 degrees and I go adjacent, which is square root of 3, over hypotenuse, I get square root of 3 over 2. 45, if I pick any one of the 45s, adjacent would be 1 over square root 2, which we could rationalize and get square root 2 over 2. 60 would be 1 over 2, or 1 half. And then 90, which doesn't show up in our picture, but if we go back to our unit circle, we've that ordered pair up there, and so 90 would have a cosine of 0. Now, just one observation to make about these numbers. Hopefully you notice that as the angle got bigger, the cosine value got smaller. Starts off at 1 and ends up at 0 when you go from 0 to 90. For sine, that's kind of opposite. Sine of 0 is 0, and sine of 90 is 1. And then it's pretty much the same numbers, but just in the opposite order here. So sine of 30, so if you go to 30, 30 would be opposite over hypotenuse, so that would be the 1 half. Sine of 45, we get 1 over square root 2 again, so rationalize that to square root 2 over 2. And 60, we get the square root 3 over 2. Sorry, square root 3 over 2. Okay? And that's a very, very quick version of that. Now, we're going to use those values to make a nice pretty chart representing the first quadrant of the unit circle. And I'm going to label some information in this chart, starting here with that 0 degrees or 0 radians. And that has an ordered pair of 1, 0. and this up here has an ordered pair of 0, 1. And in any ordered pair, make sure I get this on screen here. In any ordered pair, it's cosine, comma, sine. Okay, the x-coordinate would be the cosine value, and the y-coordinate would be the sine value. So if I start in at, say, 45 degrees right here, I get square root 2 over 2, comma, square root 2 over 2. And that would be 45 degrees or pi fourths. If I go 30 degrees, okay, so 30 degrees or pi 6, I get the cosine of square root 3 over 2 and the sine of 1/2. And if I go for 60 degrees, so 60 degrees or pi thirds, I get the ordered pair, of 1/2 square root 3 over 2. Okay. Now, you should be able to, from memory, generate this. Now, I'm going to add one more layer of depth to this, and I'm going to add the tangent. The tangent is y over x, or sine over cosine. Okay, so I can go back in. I'm going to add one more number on this. I can take the y value divided by the x value, and that'll give me a whole new number. And that'll represent the tangent of each of these angles. So if I take 0 over 1 here, I get 0. So the tangent of 0 degrees is 0. If I take 1/2 divided by square root 3 over 2, I should reduce down to 1 over square root 3, which gives me square root 3 over 3. If I take square root 2 over 2 divided by square root 2 over 2, I should get 1. If I take square root 3 over 2 divided by 1/2, I should get square root 3. And if I take 1 over 0, I should get undefined. Okay. Now, here's my suggestion, because we're going to go to a different page. We're going to go to a bigger chart here in a second. My suggestion is know this first quadrant backwards and forwards. You should be able to, from memory, recreate everything that you currently see on the screen. If you can do that, you'll do just fine when it comes to figuring out sine and cosine and tangent values of things. I'm going to review a little bit more in depth on this, but if you can see this, you should be able to get it just fine. Okay. Okay, so on the next page, you should have this chart here. And as stated, if you know the first quadrant backwards and forwards, you should be able to generate that first quadrant. The rest of the graph, you should be able to fill in just using some logic deduction techniques. So I'm going to let you take some opportunity to fill this in, and then I'm going to give you a reference to a filled out unit circle chart and let you kind of compare how close you got. So at this point, I would say pause the video, see how far you can get, what you can fill in as far as sine, cosine, and tangent, and then all the angle values. Again, from memory, you need to know the first quadrant, but everything else you should be able to deduce based on what you recall. And then I'll actually put up a completed example in a second. Okay, so here's an illustration of this with the radian form and the angle form and sine and cosine shown. So hopefully you can just kind of compare for yourself and see how close you got. I'll kind of scroll this down, and you should see this resource in the back of your booklet actually. So in case you hadn't seen that yet, then you can see the full detail down there. All right, and then the other comment I'm going to make as we go back to here, okay, take a moment and when you're ready, so after you've looked up practice this. And again, this is a great flashcard fact moment. Um, see if you can figure out the rest of this chart, and I'll fill in the answers here in a moment so you can see how close you got to that. Okay, so as you're looking over this, these are, I just picked 12 random questions. Honestly, in calculus and trig, the assumption typically is that you can actually do this, all of it, on your own, and it's just nice to go out and practice. But again, flashcards are probably the best way to go. So good luck.